All right, we can go ahead and get started. Looks like we've got a quorum here. Excuse me, I apologize. I've got a little bit of a cold that's going around, so a little bit of a cough this morning. Hope everybody is doing well. Does anybody have any announcements or exciting things that they would like to share with the group?
So I would like to share the new blog policies that we just did. So I'm putting the link to the blog post. You can find more information there. As we have often said in this meeting, documentation is a great place to start, and a blog post is definitely now a very viable option. We have a whole process and how can you add your content and what type of content is being accepted.
Yeah, it's really awesome. Thank you, Riggs, for taking the lead on that.
Riggs, do you want to summarize the policy that we came up with?
Sure.
Words are hard this morning, okay?
So there are basically four types of content that we think are appropriate for the blog. So the first is if you're writing a post detailing your experience using Istio and configuring it, particularly if it's something new and something that no one has ever tried before. So that's very good content for the post. Also, if you're highlighting or announcing new features, if you want to announce or recap an Istio event, that's also a great blog post. And lastly, if you want to post some details on how you accomplished a task or fulfilled a specific use case using Istio, that's the fourth type of content that should go on the blog. So. You're on mute, Dan. I cannot hear you.
And we specifically talked about things we don't want, that we don't think are right for the blog. You want to describe that? Because I think that was interesting.
Sure. So it's very important if you want to have, for example, detailed steps on how to accomplish the task. And not only that, but you want that procedure to be kept up to date and tested and maintained, then that type of content should not go in a blog post. It's very important that you understand that if you publish a blog post or instructions in a blog post, that content won't be revisited as the software keeps changing. So it might be better for you to consider actually adding a task or an example to the documentation or to the setup page to make sure that we keep our content up to date.
Right, and the goal there is that we can communicate clearly to people who go to the blog that the blog is not reference documentation, and if you're writing something that is essentially a sample or is a good reference, you should put that over there. When people look at the blog, they should understand that was someone's experience at a point in time, not here's necessarily best practice for this thing or a reference for that thing. If what you're writing is a reference, go ahead and add that to the reference section.
Definitely, and as you say, it's important for the discoverability of content to make sure that we are reaching the right people at the right place with the right information. So that was it for me, April. Thank you.
Thank you. And
thanks for
you,
Riggs.
Thanks for Coyote.
And Riggs, thank you for taking the initiative to say, hey, we need to have policies around this, so that the reader knows what to expect there. I appreciate that.
And it also helps us maintain the documentation repo, because now we have clarity of what we can accept in the blog posts and everything, and everyone can know what to expect. So yeah, this was definitely something we needed.
Awesome. Yeah, thank you to the anonymous Coyote who's taking notes in the community doc. Who knew coyotes could type? All right. Anybody have anything else that they would like to discuss, share, good sailing puns or jokes?
We had an interesting idea yesterday. I won't say we. Jace, who works in the who works a lot in the Kubernetes community and working groups, had an idea for us, and he said, one thing we might consider is on a regular basis, and with the number of working groups we have, this might mean quarterly, have working group leads do a kind of status update to
Yep.
the to the community as a whole. It wouldn't be that much work, I think, for any given working group, but just a, hey, here's a chance to present to the community. Most of us don't go to all of those meetings, but everybody's probably concerned in the big moves that are being made in any of those. So
Yeah.
that was something I wanted to ask the group about is, do people feel like that would be getting too specific and would take too much a chunk of this, or do people think that that's a good idea that I should go propose to the working group leads? Any discussion?
Well, it's actually part of the working group charters that they will do that. So
Okay.
I think it's yeah, it works well for Kubernetes. Kubernetes, of course, has so many things that they actually rotate out how many people, each one has an assignment. And with Istio, there are some that are not as active in the with like new architecture, new things that are being proposed. So sometimes the updates are not that exciting. But yeah, one of the things in the charter is that they should all be sending out notes from meetings and coming to this meeting and doing kind of a recap. So yeah, that would be
Okay.
awesome.
Okay, great. I loved that idea as soon as I heard it. And so I'm going to propose that to the working group members, that we establish a quarterly schedule for them to, and I'll guess quarterly-ish schedule for them to come and kind of do a presentation on what's up with the working group. Good, great.
Yeah.
Any disagreement? Anybody thinks that would be a waste of this time? I don't see anyone waving. All right, awesome.
Yeah, oftentimes when some of the working group leads are on the call, if I see them, I will put them on the spot. So they should,
Yeah, we'll put them on the spot in advance. We'll get slightly higher quality material that way.
Awesome. Anybody? I see there's a question in the chat about old sessions. Those are on our YouTube channel. It should be linked in the working doc, but I can also add it to the notes for this meeting too. And so this one is recorded and we will have it on the YouTube channel later today. All right, if nobody has anything else that they would like to share, we can switch it over to the IBM folks who have a pretty awesome update demo for us. Lynn, or not sure who's going to be the lead.
Yeah, so we have Itai on the line. We just want to give everybody a little bit of education on the multi-cluster single control plane, and also the support that we added, split horizon support in 1.1, and also the multi-cluster the other multi-cluster single Istio mesh support. So it's a little bit confusing topic, but we want to kind of educate people on what it is, what's coming up in 1.1 in this space, and get some of the feedback from the user community too. So I would love to have Itai take over. I believe he built a couple of charts to take the team through on this topic.
Yep. Can you hear me okay?
We do.
Yep.
Yeah, okay, and I'll share the presentation. Let me know that you can see it.
Yep, we can see it.
Yep, okay, good. So as Lynn was saying, the idea today is educate on what's happening with multi-cluster support in the upcoming release, 1.1 release. And not only use that opportunity for education, but also use it in order to solicit feedback from the community and ask people to tell us, are we doing the right thing? Is this what you need? Do you need something else? There is an accompanying questionnaire that I'll share the links afterwards on the chat itself. And there, whatever you can tell us and help us to understand, is this sufficient? Is this what you need? It will help shape what we deliver in Istio for multi-cluster. Before we sort of go into the actual implementation, I just wanted to take a minute maybe to go into what do we mean when we say multi-cluster. And I think to a lot of people, it's somewhat context dependent in the sense that what it means to have a multi-cluster Istio would depend on your use cases, how you want to use it, what you want to get out of it. And I think this was the source of some confusion within the community towards the end of last year. And there was work that was done, I believe, by Louis and Sriram in two separate occasions that tried to give some common definitions that the community could agree on and then work off of that. And what we ended up defining, I think, is cloud, which is basically a specific cloud provider, and that's not part of multi-cluster. But a lot of people did confuse multi-cluster MC connectivity or MC Istio with multi-cloud. That was not the intent. Then we talked about clusters, which are a set of Kubernetes nodes with a shared API masters. Of course, Istio can cater for VM and other service and runtimes, but the focus initially is on Kubernetes. So when we talk about a cluster, we mean a Kubernetes cluster. There is a concept of a network, which is a set of directly interconnected endpoints, either through some flat network that already exists within the cloud provider or the cluster itself, or it could include a VPN between different clusters. And ultimately, we want to talk about a mesh, which is a set of services or workloads that share a common administrative control and are under the same company or same team within the company. And the idea is that we're using mesh or service mesh as the foundation, and then we can build different constructs on top of the mesh itself. Now, we were talking about, mesh, cluster, network, and people sometimes assume that there's some kind of a containment or relationship between them. What we found is that pretty much any combination, any relationship, one-to-n, many-to-many, whatever can exist. And what we want to support in Istio is ultimately, of course, everything. But the order in which we do this is going to depend on what the community needs, what is the prevalence of each one of the use cases, and then get support earlier for those cases that are more common. At a high level, I think that there are two paradigms or two patterns that we've seen. One is a single mesh, which means multiple clusters connected or interconnected and have a single logical view of all of the services. Services are shared across multiple clusters. They ultimately behave as one cluster from an Istio perspective. Now, whether this is implemented using a physical single control plane or implemented as multiple synchronized control planes across multiple clusters using GitOps or some other kind of management tooling, that's going to depend on the way you do it. But ultimately, this is a set of clusters that are part of the same mesh. And the other typical use case that we see is a federation of meshes, relatively independent meshes under different management or administrative domains. And you want to selectively expose services or share services between the different meshes that exist. At a high level, just to give people, sort of an idea of what a solution or implementation would need to cater for, because that's going to drive the differences or some of the design decisions that you'll see later. In order to complete a connection from one cluster into another cluster or from one mesh into another mesh, you first need to resolve it on the client side, establish a connection from a networking perspective from source to destination, go through all of the routing required, be it directly or through the egress and ingress gateways between the different clusters, get the connection accepted by the envoy on the remote end side, and then make sure that it is allowed, do Istio security policies, connect to the mixer, return the response, and get all of the operational data that Istio needs collected somewhere within the mesh. do feel free to just interject with any question. Just stop me whenever. I'll try and keep this short so that we have enough time towards the end for discussion. But if there's something that is urgent, bring it up, please. For 1.0, we had a single mesh, and there was an implicit assumption that it can span multiple clusters as long as you have a single network across those clusters, meaning that you have a different set of addresses in each one of the clusters. There's no IP reuse, there's no pod IP reuse, there's no service reuse across the different clusters. But still, those addresses are going to be routable. If your deployment can satisfy that, then you can use Istio 1.0 to create a single mesh out of the box today. It just works. And you could extend it to support non-flat networks by adding VPNs, NATs, etc. And you can extend it to support mesh federation of sorts. And all of these would require manual effort where you have to go in and configure all of the Istio bits and pieces to get the connectivity set up correctly. One thing to remember is that we still assume that the services, namespace, services accounts, everything is going to have to be the same across your clusters because everything will have to be joined together at the end. What does it look like, picture-wise? We have a single network. We have only one cluster running the Istio control plane. Let's say it's cluster 1, runs Pilot, Mixer, Citadel. The remote clusters like cluster 2 are going to be running a smaller installation, that only includes the Istio injection and the remote part. And when you're obviously going to make a connection, you're going to get from the DNS resolution, you're going to get an IP that belongs to a remote cluster, let's say. But because we are assuming that the IPs are unique and the network is entirely routable, you should be able to make a connection across the flat network from cluster 1 into cluster 2. That's what we had in 1.0. Any questions on that? Okay. In 1.1, we're introducing 2 different things. The flat network is no longer a requirement. We're introducing the concept of split horizon EDS and SNI-aware routing as one solution. And there's going to be cluster-aware service routing as another type of solution. And each one of these will be probably a better fit for different use cases that you have. So split horizon EDS basically means that each cluster, and maybe it will be easier to see it in the picture, each one of the cluster is going to have some kind of a logical label or a network name that you can associate with it, and is unique. Whenever each one of the endpoints reports its information, it will get picked up by Galley in the future, let's say Pilot for now. Those things are changing, but each one of the endpoints, be it V1 or V2, is going to be associated with a network name indicating to the Istio control plane where, in which cluster or in which network that endpoint resides. If it's in the local cluster, which is probably a bad name, but what we mean here is the master cluster or the hub cluster where the Istio control plane runs, or it belongs in one of the remote clusters. When a client, let's say the sleep.sample pod in the local cluster, wants to make a request, it also provides Pilot with its network label. So Pilot is able to know where each caller is coming from, and based on the location of the caller, it's going to provide a different view of the endpoints that Envoy can use for doing the routing. So in the example that we have here, because V1 is local in the same cluster as the sleep sample, Pilot is going to configure Envoy with the 10.0.0.80, which is the pod IP. However, V2 endpoint belonging to the same service runs in a remote cluster and is tagged with a different network name. And since we're no longer assuming a flat network, the routing from sleep is going to go through the Istio gateway on the remote cluster. So the endpoint for V2 is going to be the Istio gateway IP on the remote cluster. When it actually makes a request, it will be load balanced between V1 and load balanced through V2 through the Istio gateway. In order to make this MTLS work across clusters, there is a shared root CA, which is common to the Citadel that runs on the remote clusters and Citadel that runs on the local clusters. There are examples on how to configure this, but it's one of the things that need to be configured correctly in order to get MTLS working across the clusters. When we make a connection from the sleep into V2 that's going to go into Istio gateway, the SNI name, the server name indication, which is part of the TLS establishment, is going to contain a clear text which says, I'm trying to access hello world.sample, which means that the Istio gateway would actually be able to see and route based on that information because it's in clear text, and would be able to accept the connection coming into the cluster and route it correctly using the SNI information into the second version 2 running in the remote cluster. Is the flow from client to server clear? Questions?
Yeah, I have a question more for the locality
Sure.
of the rules, right? So one of the key use cases here is to make sure you stay local and only load balance remote. So some cost is really the concern between regions and between zones on clouds. So that would be my only. The rest is fine, but load balancing, that information that tells you, yeah, it's more mainly failover, but not round robin or percentage based.
Absolutely. I think that that is definitely one of the things that needs to be improved. I think right now it's going to basically do weight-based routing, where the weight that is assigned to each remote cluster is dependent on the number of instances. So if we had 5 instances on the remote cluster and 1 instance locally, the weight distribution is going to be 5 requests going over to the remote and only 1 request going over to the local one. I completely agree with your statement and the sentiment that this is not likely the typical load balancing scheme that you would want, and you would want to keep as much as of the traffic as possible local within the cluster, and only fail over to the remote cluster when possible. This is definitely an area that needs to be improved.
I have a question. How, in this architecture, how do you intend to address, let's say, multiple ingress gateways for, let's say, multiple protocols, like one using HTTP, one doing TCP, or let's say even the single Istio gateway doing TLS and non-TLS, stuff like that, right? Yeah.
So I think that we are overloading the SNI information to include the target service that we want, as well as the IP that we're trying to access. All of that gets bundled into the SNI. So the Istio gateway that you have has sufficient information to route it to the correct place. I think if you wanted to separate into different gateways and have control over, if I'm accessing, a hello world, it needs to go through gateway 1, and if I'm accessing a different service, it needs to go through Istio gateway number 2. Mm-hmm. I'm not sure that can be done in this design right now, in this solution. It's something that needs to be extended and built into it.
Sure. So
the other solution that we have actually gives you more control, because you can explicitly specify which services are exposed and which gateway is being used to expose those services to remote clusters. So it's not that the 2 designs are completely the same in terms of features. There are certain features that are going to be available in one and not in the other. But ultimately, we want to be able to, sort of address all of the requirements. And if this is a requirement for you, I would ask that an issue is filed, or we are somehow have a better understanding of your requirements so we can start to address it.
Sure. So basically, what you're saying is, as of today, with Split Horizon, I cannot have two gateways defined under mesh networks, correct?
That is my understanding. Lynn
Yeah. So
or Yossi or someone else who knows better.
Can you repeat the
So I
question?
guess,
Yeah, can you repeat the question, please? Sorry.
yes. Sorry, Manish, let me just ensure that I understood the question. You're saying that in the picture that is being put up here, the gateway is associated with a cluster, with a remote cluster, and you may want to have a case where you want to associate different gateways with different services within the remote cluster.
correct.
So you could say, service 1 through gateway 1 and service 2 through gateway number 2.
Correct. Completely dependent on how the services exist. For example, one of them is a secure service, one is insecure, or one is using a different protocol than the other service, or one is using a different security profile than the other service, right? So would make a lot of sense that we create multiple gateways for those. And I was wondering if I assume under mesh networks you could specify multiple gateways.
Oh, yes, you could. Yeah, that's totally supported. You could have multiple gateways. You could also have private gateways that maybe within your network boundary. You could also have public gateways.
Correct. That is fine. But then how would the architecture determine which gateway it should be using, depending on the service? At what point do I configure that?
So when you bind a service to the gateway, you have to specify which gateway is referring to, right?
As about a virtual service? Is that what you're saying?
Yeah, so I'm trying to think. So you should be able to have multiple gateway, and then within your gateway definition, I believe there's a namespace that at least allows you to specify that's a given gateway within that particular namespace.
Okay. Maybe I could give it a try. Yeah.
Would that also work cross-cluster? So could you use the Istio ingress gateway and create? So basically what you want to do is when Sleep on local cluster makes an outbound connection, depending on the service that it wants to access on the remote cluster, it should get a different gateway from the remote cluster.
Correct. Yeah.
In the chat, Osman has sent a link to an example of in existing 1.0 a gateway with multiple hosts. So people might want to look at that. And there was a question from John at Zendesk, and he said, "Does this require still consistent naming of namespaces, services, and service accounts?" I think certainly this does require consistent naming of namespaces and services, right, Itai?
Absolutely, and service accounts and services and everything needs to be done. And we think that this, falls squarely within, if you have multiple co-located clusters, with perhaps small delay, small latency next to each other, and you want to group them together into a larger cluster in order to create, isolation domains, fault domains, high availability, capacity, whatever you want to use that, as long as they're close by. This seems like a good match from an architecture perspective to organize the multi-cluster.
I know that Envoy has kind of zonal aware load balancing. Is there anyone on the call who knows about those features and how they might interact with this feature? Because I'd be curious to know. There are times when you're right, when they're close by and you don't mind load balancing between them. But as someone asked earlier, there are times when that other one actually is far away. You might not only incur latency, you might incur cost hitting that other one, and you only want to do that when necessary. So I do know that Envoy has some zonal aware load balancing features, and I do know that Louis Ryan has done at least some thinking about how we would ultimately take those into account, but I don't know the status of that with respect to what's being built in 1.1. Sorry.
Yeah, I remember somebody added support for zonal aware load balancer within a single cluster in 1.1. I don't think it's being added or validated beyond single cluster.
But
Let me
it's
take a
the
note.
same pilot, right? So pilot, whenever it creates the response to EDS and it takes into account multiple variables, one of them is this affinity zone or the zone of the endpoints, then it's only one additional argument, the network that it's coming from. So if zone aware is working as expected before this change on a single cluster, then it will also work on multiple clusters.
Thank
Yeah,
you.
pending validation, because without the zone, you would treat the hello example V1 and V2, and even if you have multiple instances of V1, it would be treated the same, even though maybe your local cluster, you want to reach it many times beyond even get to the remote cluster.
Yeah, but V2, the endpoint for V2, or at least the public IP of the gateway, this endpoint is going to have the zone, the affinity zone of the remote cluster, right? So it's not going to hit this endpoint normally. If that's how the affinity zone is working today.
So are you saying, so I think this example might be a little bit confusing because you have V1 and V2 onto local and remote cluster. What if your V1 is also on local and also remote, and then you were trying to reach out to V1 of your Hello World from local cluster? Ideally, you want to hit that version 1 of Hello World probably 100% of the time, unless your local cluster is down. But I don't think we have the intelligence today to be able to tell, hey, okay, I have two cluster, both are on, and I have two cluster, and then the same replica for Hello World for a given version is also running on both local and remote, and I have the intelligence to go to local 100% of the time unless it fails. I think so it's a round robin today. Is that not true?
But this is the default traffic routing, right? It's like you can modify that with a different traffic policy.
Right. So the default is 50-50 among your Hello World based on the number of replicas for version 1. And then you could potentially specify traffic policy.
I believe that the comment that you made that it needs to be validated so that we understand the actual behavior with zone-aware load balancing makes sense. Is it enough to prefer one zone over the other? Should we also take into account latencies? Because the fact that two things are in two different zones doesn't mean that they're really that far apart. Maybe you can select them. If they are 80 milliseconds away, across the continental US, then maybe it's not such a good idea to fail over to another zone. Those are definitely things that we should validate.
Yeah.
Yeah, I agree. Yeah.
And Ajit asked a question in the chat. Can the gateway that's shown in the slide provide high availability or redundancy to the external network? And he adds, please. Can you configure a gateway such that it is?
Oh yeah, you can specify multiple number of replicas for your gateway.
Yeah, you would use
the normalist gateway over there.
Yeah.
Nothing special about it.
Yeah, it's just a Kubernetes deployment where you can specify auto scaling associated with it. I believe it's actually default. We have auto scaling enabled for our gateway, and the number of minimum replica is 1, maximum is 5 as the default today.
I just have a quick question. So for two services that are communicating with each other in the remote cluster, does any part of the data path have to communicate with the control plane in the other side, which I'm calling here local, but is I guess remote for those services. Because we've seen
So
like when policy enforcement is enabled, we've seen that the control plane actually ends up in the data path for some evaluation.
Right, only for mixer,
Yeah.
right? Only for the policy check for policy. I guess we split mixer into telemetry and policy. So the only thing that's part of the data flow needs to reach back to the control plane was to check with policy if this call is allowed. And we also have a cache on Envoy sidecar. I believe it's around 1 minute. So if you did that check like less than a minute ago, we'll just check with the local cache on the sidecar without going back to the mixer backend to do the whole validation.
Okay, and I guess kind of related, like, is there plans to have like some sort of like pilot proxy on the remote side so that all the envoys don't have to go across the pond to talk to the other control plane?
Yeah, so there's a plan for Mixer version 2. I believe that's being actively developed to push many of the Mixer policy function down to the Envoy sidecar. So you would actually be able to do the checking on the client side to have a little bit more distributed Mixer policy than centralized today.
Okay, and what's the
But it's
target?
not in 1.1, yeah.
Yeah,
I don't know the
not
exact
1.1.
timeline, but it's definitely not in 1.1.
So does that remove mixer altogether, or mixer still exist?
So this is what I propose. The essentially mixer would not have to exist. That you could have this. There's a bunch of work going on with WebAssembly in Envoy, and that work will enable us to take the logic that's in Mixer today and literally push it into Envoy, so that no, you don't have to run a service called Mixer.
Got it. Perfect. Thanks.
So that's the goal, and this is a perfect thing for the policy and telemetry group to come present to the community about.
Yeah. Yeah, I guess it's more an issue for policy. Telemetry, and thankfully, it's not blocking your call as part of your data plane, so it's less an issue. But policy, because you have to kind of wait until that policy check finishes if the local cache doesn't have the data. Yeah.
And specifically, we've found issues where if you get to that point where the cache needs to be refilled and the control plane is experiencing some kind of an issue in terms of resource usage or something, then it just can't fill the cache. And then it ends up 503 requests. So yeah, I guess this is good.
I just had a question about the documentation on using multiple gateways. I just posted this issue in the chat there, which is kind of, I guess, some like issue-based discussion where, or a pull request where I think, Lynn, you talk about being able to implement different gateways using the modifications to the Helm charts. So is this kind of the only place to really use as a reference for implementing multiple gateways, or is there some kind of documentation around that? Because right now I've just been kind of going in there and trying to figure out how to go about that.
So in terms of documentation, I'm working on updating the traffic management concept, and that includes an entire section on gateway behavior. And we also have some tasks that one of them, the Ingress gateway task, was already linked in the chat. That also give more information on how to configure multiple gateways. But it's definitely something that we need to keep working on, having better documentation around it.
Okay, yeah, because now it kind of seems like when you're doing the multiple gateways, let's say you're on a cloud provider that provides you the single load balancer. So if your provider is only giving you the single load balancer, you wouldn't be creating multiple load balancers on a single cluster. So in a sense, your gateway would only have one IP address to actually one gateway IP, and then you're using kind of this multiple host thing that I posted in the chat. So I think my question is, if you only have a single load balancer on your cluster, so you only have one external IP address, are you really creating multiple gateways because, or are you just kind of using one gateway and then substituting that gateway for multiple hosts? What's the approach there? Because on a lot of clusters, you only have the single external load balancer.
So you may have like a single Istio gateway, but you can have multiple gateway objects, Istio gateway objects connected or binded to that Istio gateway. Each one of them is either choosing a different port or a host, and part of the information that you get in the SNI is the port number that you are going to target, and based on this port number, the internal routing within the remote cluster is going to happen. So you have only single Istio gateway, but you have like multiple gateways binding to that. Virtual services binding the gateway to the local services.
And then another user scenario I can see is maybe you have one Istio gateway that's bound to your public IP that's more out-facing outside of the mesh as the entry point into the mesh. And then you could also have Istio gateway that's bound to your private IP, not so much. It may be a private IP like 10 dot something inside of your inside of your network, but not necessarily exposed to the public internet, so that it would allow you to bridging the connectivity among like the local and remote cluster in this case. So I believe that's possible because I've run multiple gateways in the past. It's just it can be bound to different endpoints.
Okay, sounds good. So I guess right now the approach I've been using is the one I posted there from the documentation with the SNI based with the external IP. So I'll just use that, and then I'll also try your internal suggestion. Thank you.
Yeah, but I think one important thing that we forget is having the, think about one of the best current scenarios, right, of this is regional failover for clouds, right? So this is one good use case for that. So make sure that we have, one is ingress for external traffic and one is chat is to that. So it's not really the Istio gateway, but really having two mechanisms to communicate between the clusters, right? I'm not sure where that fits in, but I would probably say that, internally you go between clusters and that's an internal traffic, and how you come into the cluster is external traffic. So the ingress and mapping to that ingress is one thing we should make sure it's clear, and probably not have them coupled to try to separate all of them together, because there's two separate things that you're trying to do. And configuring this Istio, the gateway configuration becomes a little bit brittle, as you try to do too much in it. That's my 2 cents.
I think the comment that you're making is it needs to be clear in the documentation and the tasks, concepts, etc. How do you clearly configure an externally facing Istio gateway and another one that's being used, one or more that are being used for internal communication between the clusters? I believe that was the comment, the request.
And if we do that, then and it's a cleaner, then you can kind of focus that this is a common use case that we'll see, I guess, in the more complex manner, because that's what happens is the samples usually are very simple, and then when you try to extrapolate, you get in a whole mess of trouble when things start getting complicated, and then we'll talk about operation of the Istio cluster, where like Kubernetes and I think now Istio community tends to kind of say, well, how are you going to operate this mess? And when there's a problem, right, problem detection still is a challenge on these environments.
Can I ask who is that last voice? Who was
That's
talking?
Jose,
I
Dan.
thought it was you, Jose. Okay.
Okay.
Good to hear your voice. And the second is, okay, I was checking on content. There are more slides than a demo, so we should probably get to the other slides, and I definitely want to see the demo. In fact, feel free to skip the demo if you want to.
Okay, so just at a high level, there's another system which is more about independent meshes that can be tied together. And the idea here is that when you first try and resolve the service name locally, if that fails, we're assuming it belongs to a global scope and we're going to try and resolve it. If the service is indeed exposed from some remote cluster, it would have been populated within the local cluster so that you get the cross-cluster connectivity. So in cluster 1, it's going to try and resolve a name. It's going to access bar namespace 2. It will fail locally because there's no service endpoint for it. Ultimately, it tries to resolve it to bar namespace 2 in .global, which gets delegated to Istio. Istio is going to resolve it to the remote gateway and basically communicate across clusters by using the global service. So we are selectively exposing services between the different clusters. I just want to take maybe another minute to make the final comment, which is we believe that we're not aware of any limitations. All of these two features should be able to run as is out of the box. Routing security metrics should, I mean, it's a matter of getting the configuration right, of course. But other than that, I don't think there are any conceptual roadblocks in getting all of these working in the two modes and the two usage patterns that we have. And we said we're not done yet. There is improvement in documentation. It still needs to happen. Usability, cross-cluster load balancing. There are other issues that need to happen, and we are at the demo.
Hey, Itai, if you want to end your screen share, then I can start.
I believe I did.
Okay. Okay, so we only have a few minutes left, and I think there's a couple more things that we wanted to ask from the community. So what I want to show is just the book info sample that everybody knows and loves, running on the two different variations that Itai talked about, the two variations of multi-cluster support that's coming in 1.1. This does not cover the flat network approach. Both of these are ones where the pods are not addressable from across the clusters. Okay. As a quick overview of book info, the only thing you need to know for this demo is that there's 3 versions of the review service. The first one has no stars. The version 2 has black stars, and version 3 has red stars. Okay. So jumping into the first part, which is the split horizon EDS or cluster aware service routing method. What we're going to do is deploy product page, or have it already deployed, I should say. Product page, reviews v1 and reviews v2, and ratings on the first cluster, which is the local cluster or the master cluster that has the Istio, the main Istio control plane. And then the second cluster has reviews v3, which is the black star. Okay, so if I jump on over, so I'll switch my context to local cluster, and then if I do kubectl get pods, you can see I have most of the book info except reviews v2 and v3. Okay, now the second cluster, which is the remote cluster. If I do kubectl get pods again, in this case, we have, is everyone able to see my screen okay?
Yes.
Okay,
Yep.
I just made the text bigger. The second one has reviews v3 and ratings, just as shown in this diagram. So let me just jump back to my local cluster, which is the first cluster, and then get the gateway IP of my ingress gateway, the Istio ingress gateway. Computer's running a bit slow with screen sharing. If I go to product page, and if I just do refreshes, you can see it's switching from no stars, which is v1, and then red stars, which is v3. Okay. Some of the interesting things to take a look in this configuration. The setup of this multi-cluster approach is more difficult because it does require you to set up the mesh networks and tell your local cluster about all your remote clusters, and also give your local cluster the necessary config that it needs to talk to the Kubernetes API of each one of the remote clusters. So in terms of setup between the two different approaches, this one does take more. But in terms of deploying an actual application and the use case, it is more simpler than the other approach, because you have that one control plane that's able to talk to both the local Kubernetes API and remote Kubernetes API. The only thing that we needed to do to set this up in this scenario is, deploy the pods as usual for your local one, and then deploy your remote pods, and then set up this ingress gateway to allow for this pass-through. So now if I do kubectl get gateway, and then bookinfo gateway -o YAML, you can see I have two host definitions in this ingress gateway, where the first one is just HTTP traffic, normal port 80. That's for this product page. And then this TLS pass-through, which is this encrypted pass-through that's going through here. And I only have to define this gateway locally, and the configuration does get passed automatically to the remote clusters. Okay, so I think that's a quick overview of the first scenario. The second scenario, the second way to do this would be the multiple control planes approach, where both the clusters have all the control plane. So let me jump to that cluster. In this case, I come cluster 1. In this scenario, we have just the v1 versions of the bookinfo page. So kubectl get pods. You can see I just have products, reviews, and details, no v2 and v3. And then I jump to cluster 2, which is the cluster on the right, and then do kubectl get pods. I have the reviews v2 version. So this one will do something a little bit more interesting. Think of the use case of you have your production application running on your main cluster v1, and then on a different cluster you have, let's say, this canary version of v2 deployed, and you just want to route some version of your traffic, or you want to do dynamic host-based routing, where you define a virtual service and say, I would just want some of my users to get to v2 service. Okay, so in that case, what we'll do is set up a virtual service. Kubectl get virtual service. Let me switch back to cluster 1, and then try it again. And then I have the reviews virtual service -o JSON. Oh, let me try YAML. Okay, you can see here I'm saying that when the user logged in is Jason, then we want to send him to reviews v2. Everybody else gets v1. Let's check out this scenario. So again, I'm getting the Istio gateway IP address. Go back to my browser, open a new tab, and then go to this product page. And if I hit refresh, you can see that I'm always getting v1. But then if I log in as Jason, I can get traffic routed over the pond to cluster 2, and now I'm getting black stars. So if I refresh, I keep getting black stars, and if I sign out, I just get back to the v1 again. Couple of things that would be worth looking into. Let's take a look at the Envoy configuration to see how this looks. So kubectl get pods, and then grab the product page pod, and then Istio proxy config and points for the product page pod, but we just want to grep for just the reviews endpoints. Okay, as you can see here, the local ones have this local 172 IP address, and then the remote v2 versions have the remote gateway IP and that the pass-through port. Okay. One last thing I want to show is this kind of service entry. all the remote configurations in this approach do require you to create the service entry that maps that remote service to the host name of with the full host name of the .global, so it knows where it is. So if I do kubectl get service entry and then reviews dash default and look at the YAML, you can see this is how the V2 service entry is defined. We're just doing a label selector of V2, even because it's the same service. And then the host name, instead of .local, it's going to have .global. And then this address is the remote gateway address. So this does put the burden, compared to the previous approach, that every remote service requires you to have this service entry endpoint defined, where you have to define the gateway IP address of your remote cluster as well. So I think with that, I think I'm gonna hand it over. We only have 1 minute left. So we wanted to ask about the survey. So Itai, kind of back to you.
I'll just pop in here to say that, if folks need to drop off, of course, the recording will be later, but we can keep the meeting up and running as long as y'all need, so no worries.
Okay. Itai, could you quickly show the blog and the list of questions that we want people to take a look at and
Yes,
answer?
I was about to suggest that maybe in the interest of time, just post the questionnaire URL into the chat. I believe everything that we've shown today, the meeting is recorded, will be shared. The presentation is, I believe, already on the drive, right, Lynn? Yeah, I can see it on there's a link to the
it is.
presentation. Good. And we will have a blog post that basically has all of the information that we talked about today. And we, kindly request that whoever can fills out the questionnaire so that we can collect as many of the requirements as possible and make sure that we add the needed functionality to address the use cases. That's pretty much it. And thanks, everyone.
Okay.
Thank you.
Thank you.
Thanks, guys.
Thanks, everyone, for joining.
Bye-bye.
Bye.